We shall see how bank gives loan to people, and that algorithm is used for deadlock avoidance. Let us see. A bank has 100 rupees. P, Q, R are persons. P asks, P has need of 60. Q has need of 75. P is given 40 rupees. Q is given 30 rupees. So let us see what is the situation. Person given and the remaining need. The person has been given 40 rupees and the remaining need is 20. Two person has been given 30 rupees and the remaining need is 75 minus 30, 45. And available amount with the bank is, he has given 40 and 30. 30 rupees are now available. So this is at present the situation is. Whether this situation is safe. Is it correct? It is safe. Yes. We have 30 rupees available. We can give it to P. He can complete his work. So he will return 40 rupees. So 40 plus 30, 70 rupees will be with us. We can give it to Q and he can also complete his work. It is safe. Now, let P asks for 20 rupees. Let Q asks for 20 rupees. Suppose bank gives then what is going to happen? This is a situation. To Q, we have given 20 more rupees. So to Q, 50 rupees has been given and 25 is the remaining need of Q, and with the bank available is 10. Available is 10. Whether the situation is safe? It is an unsafe situation. In this situation, deadlock will take place. Because both P and Q are at present working, but the bank has only 10 rupees. If P asks, I am explaining, Nilanjan, I am explaining. Meaning of the safe is, can we give the guarantee that deadlock will not take place? Is it correct? And unsafe means the deadlock will certainly take place in future, even though deadlock is not now. It is the meaning of unsafe. At present, there is no deadlock, but deadlock will certainly take place in future. With the bank, there is only 10 rupees which is available, and after some time, P will ask for 20 rupees. Bank will not be able to give. He will say, you wait. This. After some time, Q will ask for 25 rupees. Bank will not be able to give. Bank will say that you wait. So both of them will be waiting, and no one can proceed. On the other hand, why the above is a safe situation? Suppose Q can ask for 45 rupees in future. Probably shall be coming to it. Q can ask for 45 rupees in future. Bank will ask him to wait till P is over. After P is over, he will return 40 rupees. So with 40 plus 30, 70 rupees, needs of the Q can be satisfied. So Q can also be made over. Is it correct? What is your problem? Ask your doubt. Any doubt? Let us see this situation. Whether this situation is safe. Whether above is safe. Okay. It means the bank was initially having 50 plus 2, 52, 67 rupees bank was having. Is it correct? And A needed total 32 rupees, B needed total 30, total 30 rupees, and C needed total 1 rupee. Whether the situation is safe. Is it correct? At present, available amount is 15. Yes. Yes. Fully correct. If B asks, we shall deny. But if A asks, we shall let him take. Is it correct? Now, question is this. B asks for some money. What maximum money can be given to him? Nilanjan, how you have given the answer like this? 15 minus x should be greater than to satisfy the minimum of 1, 12 and 16 minus x. Wrong, Nilanjan. Nilanjan is wrong. No. No. Maximum 3 can be given is wrong. More than 3 can be given. No, more than 3 can be given. Nilanjan is wrong. No, wrong. Altaf is wrong. Okay. Let us see this. Let 4 is given to B. Correct. What is going to happen? Let us see this. Let 4 is given to B. It means given to B will be 34. And the additional need of B will be 12. And the available amount will be 11. It is safe. Yes. Why? If A asks for 12 rupees, we shall ask him to wait. If B asks for 12 rupees, we shall ask him to wait. And we shall complete C. Let us complete C. Now, 2 plus 11 is available. We can complete A. So how much will be available? 13 plus 20 available. Now B can be completed. Is it correct? Okay. Any doubt? So giving 4 rupees is safe. This situation is safe.
Sir, the
Now,
question was that maximum amount we can give to B so that deadlock doesn't occur.
no,
No.
question is not of the deadlock. Question is that safe situation. You
So
see,
safe means the deadlock doesn't occur, right?
no, at present there may not be any deadlock, but in future it will occur. Is it correct?
Sir,
Safety of the
can you again,
situation.
yeah, explain the safe one?
I will explain to you. Let 2 more rupees are given to B. 2 more is given to B. What is going to happen? Okay. B will be given 36 and its need will be 10. So what is going to happen? And available will be 9. Is it correct? So what is going to happen? We, if A or B asks, we shall ask him to wait. But if C asks, then we will complete C. Afterwards, 11 will be available. We can complete B and afterwards we can complete A. Is it correct? So again, it is safe.
Sir, can you scroll down? There are some questions.
Yes, yes,
Hello,
yes.
sir.
Now batao.
It is unsafe condition, sir, because when
How,
9 is available,
how 2 plus 11 is available? You see, at present 11 is available. If A and B asks for their full amount, we shall deny. But we shall give that amount to C. C will complete. And afterwards, two resources were already given to C. So 13 plus 2, 11 plus 2, 13 will be available. With the help of them, we can complete A or B one by one. Is it correct? What is the problem?
sir, after a completion of C, there will be 11 available. Is that the
No, you see, when C will complete, then 2 were already given to C. So those 2 will be released. So 11 plus 2, 13 will be available. Yes,
no, sir?
not only 4 but more than 5 are also possible. Yes. What is your doubt now? Ask your doubts. Yes. Okay. Why 14 cannot be given to B? Yes. I have not told that 14 cannot be given to B. Nilanjan, you are correct. 14 can be given to B also. Is it correct? You wrote 14, I can assume. But the formula which you wrote, I was not satisfied. That 15 minus x is 1 plus 12 plus 16 minus x. You see, this formula may be correct in these circumstances, but this I was not satisfied with this formula in general. We shall create an example where this formula will fail. 14 can also be given, but not 15. Is it correct? Yes. But the formula was wrong. Nilanjan, do you agree? You are fully correct. 14 maximum can be given, not 15 in these circumstances. We shall see to it.
Okay, sir. And also, sir, can you distinguish the conditions of safe and deadlock? I didn't understand that.
Deadlock basically means that two people are waiting for each other in a cyclic manner. That is deadlock. And unsafe means at present no one is waiting. No, every person is working. But in future, they will certainly be waiting in a cyclic manner and deadlock will take place and we are in a position that now we cannot do anything. I will explain to you. Now, how many maximum resources can be given? Let me call it UVW. Is it correct? No, wrong. Tushar is wrong. How many? Tushar is wrong. Unsafe means available is less than additional need of all the processes. It is certainly unsafe, but even otherwise it may be unsafe. Is it correct? Even otherwise it is unsafe. Is it correct? Whether, is it called correct? How many maximum can be given to you? Tell me. Answer this question. No. Yes, 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 yes. Fully correct. No doubt about it. Full 12 can be given. Fully correct. Now, how many maximum can be given to G in this case? Yes. Let 9 is given. Then what is going to happen? Available will be 6. 9 is given. Additional need of this will be is it correct? Now, at present there is no deadlock. But after some time, when anyone asks for any resources, he will be asked to wait. And in future deadlock will take place. Is it correct? Agree? Now, how many maximum can be given to G? Okay, to H. How many maximum can be given to H? Answer this question. And now Nilanjan will realize the mistake in its formula. Nilanjan, there was a mistake in 6 which you wrote. Even 7 could have also been given. Do you realize the mistake, Nilanjan, in your formula, which you gave at that time? No, answer you wrote correctly 14, but the formula which you wrote was wrong. This is greater than minimum of these 3 things. That was wrong. Is it correct? Yes. That formula was wrong. Now you try to solve it with the help of the same formula. You will find the mistake is there. How many maximum can be given to H? Let 2 are given. What is going to happen? H will have additional read of 18 and this will be 32. Available will be 13. Do you agree? Now, at present, there is no deadlock. If G and H ask for, we shall deny. But if K asks, we shall give. K can be completed. Now we have 13 plus 2 equal to 15. Neither G nor H can be done. Is it correct? So at present, there is no deadlock. So this situation is unsafe. Do you agree? You are fully correct. In which case, 15 minus x. You see, you apply this formula in this case, Nilanjan. In these circumstances, if we give 2 to h, this is an unsafe situation. Available is 13. With the help of those 13, we can complete the need of k. Available will be 15. But with those 15, nothing can, among G and H, nothing can be done. Yes. That is correct. Harshvardhan, yes. That is what I was saying. Formula doesn't consider that K has already been given 2. And Niranjan, maybe that you can send the formula in these circumstances to me on the mail. Is it correct? Yes. Send the formula, correct formula, in the mail for these. No, wrong. Jannat, you are wrong. No, Jannat, you are wrong. Forget about 7. Forget about 8. Even giving 2 is unsafe. You are wrong, Jannat. You see, we have given 2 to H. H will be having 18. Available will be 13. Now, with 13, we can complete K. We shall have 13 plus 2, 15. Afterwards, nothing can be done. Do you agree? Yes. At most, one can be given. Yes. Fully correct. At most, one can be given. Yes. Ask for doubts. Any more doubt? No, it is not a hit and trial. There is a method to do so. There is a method. We shall see to it. Please answer this question. It is not clear. You see, Kasif, it will be unnecessarily not giving. We should deny the resources when there is a guarantee that the problem is guaranteed. Is it correct? If we said unnecessarily deny, it means that we are blocking unnecessarily concurrency. We will like to give as much facility as possible, provided that we are within safety constraint. Is it correct? Have you understood, Kasif? Why to unnecessarily deny? Please answer this question. How? Let let 16 is available. We can do A and B. A and B can be done. Now 16 plus 5 plus 2 equal to 23 available. Now C can be done. Is it correct? So 23 plus 6 equal to 29 available. Now D cannot be done. Is it correct? Fine. So there should be available at least 16. Now, next comes this question. How many maximum can be given to A, B, C, D? A, B, C, D. Answer this question. How many maximum can be given? Harshvardhan, I could not understand how you wrote this formula. Okay, how you got 20 minus 15? How from where you got 15? That I could not follow. Nilanjan, you are wrong. Nilanjan is wrong. Tushar is wrong. Nilanjan is also wrong. Gyan is also wrong. Gyan, reconsider your D. Pranav, reconsider your D part. Reconsider your D part. Gyan and Pranav. No, I think it is wrong. No, Jannat, you are wrong. Gyan, you are wrong. Again, you are wrong, Gyan. No, Jannat, you are wrong. Let us see this. Okay, yes. Now correct answers are coming. Let 6 are given to D. And what is going to happen? Now, let 6 are given to D. Its additional need will be 24. And given to this will be 10. Now, remaining is 12. Remaining is 12. We can do A and B. Is it correct? So, 5 plus 2 equal to 7 plus 12 equal to 19. Now C cannot be done. Is it clear to you? Now, let n is given to C. Then it will be 10. It will be 16. 8 is available. Now, A is done. 8 plus 5 equal to 13 available. B is done. 13 plus 2 equal to 15 available. Is it correct, Nilanjan? Agreed? C can be done. Agreed? Yes. Okay. Now, ask your doubt if any. Ask your doubt if any. Any doubt you can ask. Any question. I would like that you design a general method. Is it correct? You design a general method. It can be designed. A computer program can be written. Is it correct? Yes. Write a computer program. And let me see. You try to send me a computer program on mail also. Is it correct? A general n resources are there, and there are two arrays. G array, which stores the given, and A array, which stores the additional need, and remaining or is R. Using this, find a general method. How much maximum can be given to an arbitrary process? Is it correct? Send it in mail. Now, any doubt? It is not clear to me how you are writing this formula. Is it correct? It is not clear to me. Okay, how you wrote this formula. Okay, 18 minus x. No, some intermediate check may also be required. Harshvardhan, here the circumstances were there, so you could have done it. But always this formula will not work. You send me in the mail by giving the complete context of the problem. Is it correct? Then I will change the data so that this formula fails. That is correct. Yes, you are correct. Minimum available required is M. It should be greater than A1, A2 minus G1, G1, that is correct. Now, also write a formula. How much maximum can be given to any one of them? Is it correct? You also write a formula for that. Is this correct? Yes. Now, what are you writing, Jannat? I cannot follow you. Now, let us see this problem. What is the difference between deadlock avoidance and deadlock prevention? Suppose this situation has been given to you. Then, why the deadlock takes place? The deadlock takes place because of the cyclic wait. What will happen under these circumstances? Let us see what is going to happen under these circumstances. C will execute from 0 to 10. And afterwards, it will execute from 10 to 17 with using P. Now, we will execute from 0 to 5. And afterwards, it will execute from 5 to 13 using Q. Now, it waits for Q, which is at D. And it waits for Q, which is with C. So it is a cyclic wait which is taking place. Is it correct? How to remove cyclic wait? Because it is waiting for Q and holds P. It is waiting for P and holds Q. So it is cyclic wait. You hold P and wait for Q. Hold Q and wait for P. How to remove cyclic wait? Do not demand a resource lower resource and higher resource and hold higher. Let us assume P is lower and Q is higher. Let us assume this. Let us make some policy. Under this policy, we shall say that our job requirements are being turned like this. First, even if you need P later, you should demand P earlier so that hold of Q and need for P is not the case. This is deadlock prevention. Deadlock prevention is more restrictive than deadlock avoidance. Here it blocks concurrency more. You can try to answer what is the disadvantage of this and what advantage the deadlock avoidance has. Is it correct? So this is how to remove cyclic wait. Deadlock prevention. Is it correct? Deadlock prevent. Okay, how we can prevent the deadlock? Class is over. I need PQ. Reason is this. After class is over, any discussion can be done. Why need PQ? Because once we write need Q, later on need P is not permitted. Why? We are making a policy that when you are having a higher thing, Q is higher, then lower thing you cannot demand. Is it correct? Do you understand it? So what we do, if you need Q, before that you should need P. So from time t equal to 5 to 13, even if P is not needed, you must demand P. Is it correct? Yes. Any doubt? Any doubt? And I am putting it in the chart. Any question can be asked.